primarily on hand hygiene is critical to disease prevention. We're going to help you gain greater understanding about products, hand hygiene products, soap and sanitizers, antibacterial products, and then we're going to talk a little bit about available consumer education resources that are free from the partnership and from the CDC and other sources. So that's what we're going to cover today. Now to our few housekeeping items. At any time, please feel free to type your questions into questions or chat on your screen. You should see that in your participant box on the right-hand side. We have a post survey. It will launch immediately following the webinar. So please take that post survey. It really helps us to serve you better, and that's why we do these webinars, is to help educators across the country come up to speed on issues and be informed about new products. The CEU certificates for CDR and NEHA are included here as handouts. I called it attachments here, but it's called handouts. If you look over again to your box there, you should see that there are 3 handouts, and those forms are in there. So I'd encourage you to download them now. That will make it a lot more efficient for you to get your form for your participation. So I wanted very briefly to talk about some of the recent observational research. This is about consumers and their food handling practices. Dr. Christine Brune of UC Davis observed people preparing chicken in the home and found that 65% did not wash their hands prior to preparing the meal. 40% did not wash their hands after handling this raw poultry product, and just 10% washed their hands for 20 seconds or more. And a third did not use soap. So we know from this and other research that consumers may be aware that it's important to wash their hands. They're not necessarily consistent. In other observational research, Jeannie Sneed and her team observed meal preparation at home, found that participants who received education on food safety messages had higher hand washing scores, but most participants in all the groups engaged in actions that led to cross-contamination. So cross-contamination is still a big area for consumer education and behavior change. We're going to launch a poll, our first poll today, and in it we're asking you, is your organization currently developing initiatives or executing initiatives that are intended to improve hand hygiene practices at home or at work? So I'm going to launch this, and we'll leave it open for about a minute. So please answer the poll, and then we'll share it with everybody. Question again is on if your organization is developing initiatives, or are you actively involved in initiatives intended to improve hand hygiene among consumers in the home or at work. Okay, in another 15 seconds I'm going to close, so please vote if you haven't. Okay, thank you for voting. I'm going to post the poll. I'm going to share it with you all. So here are results. Almost 70% of you are involved in initiatives intended to teach others about hand washing, and about 20% are not, and some of you aren't sure. So thank you for that. Very helpful. All right. I'm very pleased today to welcome Dr. Laura Brown. She's with the CDC, the National Center for Environmental Health. We're so glad she's with us today. She has a great deal of experience in the application of behavioral science methods and findings to the study of retail food safety. So, of course, hand hygiene has been a major topic that she's worked on. So, Dr. Brown.
Thank you, Shelley. Can you hear me okay?
Sound good to me.
Okay, so today I'm just going to do first a brief overview of CDC's message on hand washing, why it's important, and how and when to do it. And then, as Shelley said, because food safety is my area, I'm going to talk a little bit about the importance of hand washing to food safety, and particularly to retail food safety. So the CDC's message on hand washing is what you might expect. CDC says that regular hand washing, particularly before and after certain activities, is one of the most important steps we can take to, 1, avoid getting sick ourselves, and 2, avoid getting others sick by spreading our germs. And there's a body of evidence indicating that many diseases and conditions are spread simply by not washing with soap and clean running water. And there's a body of evidence that shows that improved hand hygiene leads to a reduction in gastrointestinal and respiratory illness. So hand washing really is considered by the CDC to be a primary prevention method. On the next slide, you'll see the basics on how you should wash your hands. And the information in these first slides that I'm presenting today is all on CDC's website. It's pretty much taken straight from that website. CDC says you need to wet your hands with clean running water, and it can be warm or cold. Turn off the tap and then apply soap. And then lather your hands by rubbing them together with the soap. And they remind you to do the backs of your hands, in between fingers and under nails. Those are often areas that people can miss. Scrub your hands for at least 20 seconds. I'm sure you've heard this before, but if you need a timer to kind of estimate what 20 seconds is, you can hum the Happy Birthday song 2 times, and that's about 20 seconds. And then you need to turn the water back on, rinse your hands well under clean running water, and then dry your hands using a clean towel, or you can air dry them. And on the next slide, you'll see information on when you should wash your hands: before, during, and after preparing food, before eating, before and after caring for someone who is sick, before and after treating a cut or wound, after using the bathroom, after changing diapers or cleaning up a child who's gone to the bathroom, after blowing your nose, coughing, or sneezing, after touching the animal feed, or animal waste, and after handling pet food or pet treats, and then after touching garbage. So as I said, I've done some work in food safety and a little bit on hand hygiene and food safety as well. So from here on out, I'm going to talk about hand hygiene and foodborne illness outbreaks. So you'll see on this slide that most foodborne illness outbreaks that occur in restaurants are caused by failures in food worker health and hygiene. You'll see 64% of outbreaks in restaurants are linked with food worker health and hygiene. And food worker health and hygiene are often sort of grouped together because it's often ill workers who aren't washing their hands properly who are spreading germs. So on the next slide, you'll see the foodborne germs that are commonly transmitted by food worker hands, and they can be viruses, bacteria, and parasites. The most common foodborne illness outbreak is norovirus. Symptoms are essentially vomiting and diarrhea. That's the most common cause of restaurant outbreaks. Hepatitis A can also be transmitted through food. And you'll see bacteria listed as well: Salmonella, Shigella, and Staphylococcus. And then parasites as well. These are less common, but they can be transmitted through foods: Cyclospora, Giardia, and Cryptosporidium. So now we'll talk a little bit about how that happens. So food workers can cause foodborne illness outbreaks when their hands are contaminated with germs, and they could be contaminated from their environment, from touching other foods, for example, raw meat that's been contaminated, or their environment, the equipment in the environment. Or they can be contaminated with germs that they're infected with, that they might either be showing symptoms of an illness or be infected and not necessarily showing symptoms. And then they fail to adequately wash their hands, and then they handle food. So the germs are transmitted through that pathway. On the next slide, we get a little bit more specific. There's a couple of different ways this can happen. The most common way is fecal-oral contamination. So essentially, an infectious worker who may or may not be showing symptoms, but they are infected, they go to the bathroom, and they clean up after themselves, and then they don't adequately wash their hands, handle food, and then the customer eats the food. So the germs are transmitted in that way. There are other ways. There's some examples here. Norovirus in particular is pretty contagious and can be transmitted through vomit. So if a worker vomits or cleans up vomit, they can transmit it in that way. Or a worker could handle something that's contaminated. They can handle raw meat, not wash their hands properly after that, and then handle something that is then eaten by a customer. So those are some of the primary ways that foodborne germs can be transmitted through food. And on this next slide, slide 17, you'll see these are just examples of, these are real-life examples of foodborne illness outbreaks. So in the green circle, you'll see a smaller outbreak. A worker who was infected with the parasite Giardia used her bare hands to slice raw vegetables for salads. And then 27 people became ill with Giardia through that process. In the blue circle, you'll see a larger outbreak. A catering worker was infected with salmonella. He prepared cold dishes and prepared quite a bit, and then they were improperly stored over several days. So through that improper storage process, the salmonella was allowed to proliferate. So there was a lot more of it over that time period. And as a result, 290 airline passengers and crew became ill, again, from salmonella. And then in the yellow circle, here's another example. 2 catering workers who were infected with norovirus. They had been sick the day before. That day they felt fine, so they were working. And they were mixing up a lot of pasta salad. And so they were in big buckets, and so they just basically immersed their arms in the pasta salad and mixed up the pasta salad in that way. And so 333 customers who ate that pasta salad became ill with norovirus. So those are some examples of how foodborne illness can be transmitted through food workers who don't wash their hands properly. And real quickly on this slide, CDC has done some research on improving hand hygiene in food service and restaurants. Now the Food and Drug Administration develops a model food code, or has developed a model food code that contains sort of recommended guidelines for food service establishments to prevent foodborne illness. And of course, hand washing is in there. The food code includes requirements on when to wash hands and how to wash hands. So that's an obvious first step. We've done some work here. We're sort of looking at how do we increase the proportion of hand washing. So here's a couple of examples from that research. We found that restaurant management should emphasize the importance of hand hygiene, that management should make sure that workers know that hand hygiene is important, and it's more important than getting the food out quickly. They should ensure that staffing is adequate. Some of our research has shown that when workers are really, really busy or they feel short-staffed, they're more likely to take shortcuts, such as skipping hand washing. We've also done some research that shows that workers who are food safety trained are more likely to wash their hands when they should. And that in restaurants where sinks are available and hand washing supplies are available and accessible, in the work environment, those workers are more likely to wash their hands. So that seems fairly obvious, but you can't wash your hands if you don't have a sink nearby that can allow you to do that. And then there's also some research to suggest that you can organize food preparation activities in a way that might increase hand washing. So if you can reduce the number of needed hand washings, you can increase the probability that workers will wash their hands when they need to. So for example, you're preparing hamburgers, and so you make one hamburger patty out of raw meat, and then you cook it, and then you go back and then you make another raw hamburger patty, and then you cook it. So that requires a hand washing in between each of those activities. Whereas you could organize the activities such that you make all the raw hamburger patties at one time, then you do one really good hand washing, and then you can move on to cooking. So there is some data to suggest that that might help increase hand washing when it's needed most. On this next slide, you'll see some of our references. The first is CDC's website on hand washing, and then the others listed there are just some of the basics on foodborne illness outbreaks. So I'll stop there. Shelley?
Thank you, Laura. Thanks very much. Now remember also, if you have a question, to type it into chat. We're going to launch our next poll. And in this poll, we'd love you to tell us about your level of satisfaction with the materials for hand hygiene outreach that you currently use in your organization. I'm going to launch this poll. I'm going to find this one. Oops. Okay, so the poll's in progress. We're just trying to get a sense of, you know, if you are doing this form of education, either of your workers or of consumers, are you satisfied with the materials that you've found that are out there that you can use for this purpose? So we'll keep this poll open for about 20 seconds. So we'd love to have your feedback on this. Okay, only about half of you have voted. Please vote, because everybody's going to be curious what you have to say. Okay, I'm going to close the poll in about 10 seconds. Please vote. Give us your thoughts. Okay, we've got 82% of people voting. And what you have to say is that you are mostly somewhat satisfied. And about 36% very satisfied. If you'd like, share some information in the survey about what material you are using and whether it's serving your purposes or not. So thank you for that. Okay. Our next speaker is someone many of you may know, Dr. Don Schaffner. He's an extension specialist in food science. He's a distinguished professor at Rutgers. His research interests include quantitative microbial risk assessment and predictive food microbiology. He's been very active in this field, and many of you may know him from his leadership in the International Association for Food Protection. Dr. Schaffner, thanks for being with us.
Oh, thank you so much, Shelley. I really appreciate the invitation to come and to speak to this group. What the folks on the webinar may not know is you've given me about 20 minutes and a whole lot of material to cover. So I'm going to move pretty quickly through that material, and hopefully I can cover all of it in sufficient detail so that everybody understands what it is that I'm trying to communicate. Shelley, I don't see the slides. I'm still seeing the poll. Is that something I should do on my end? Or do you need to do that? There we go. So as soon as I can see the slides, I will start talking. So, well, let me vamp for a little bit while the slides come up. So, you know, hand washing is something that we got interested in probably around the mid-2000s. And actually the reason why we got interested is because of a gentleman by the name of Jim Mann. And some of you may know Jim. He works now for a company called Handwashing for Life. Prior to that, he worked for Sloan Valve Corporation. And he was very interested in trying to quantify the effectiveness of a touch-free faucet system. And so Jim reached out to a mutual colleague, and we actually got started doing some research in this area, and we haven't ever stopped. It's just been a very fascinating and interesting area, and continues to fascinate me, and that's why we continue to do research in the area. And increasingly, I'm interested in policy issues around hand washing, and served on the hand washing committee on CFP, and looking forward to continued work in that area. So if you could move on to the first data slide, Shelley. So what I'm going to be talking about on the webinar today is first is hand washing efficacy. And so this is some, and I should mention that all of the data that I'm going to be presenting today is coming from either articles that I have published or that other people have published. The citations are given at least in part somewhere on the slide. So if you want more information, you can go and download those publications. So this is the first slide is on intervention efficacy, and bear with me while I explain the story that we're trying to tell with these slides. It is a little bit of a non-traditional way of explaining what's going on, but we think it is the most clear way to explain things. So in the panel on the left, we are comparing, and this is research from our laboratory, we are comparing a 5-second hand wash with no soap, what the graduate student who did this work affectionately called the splash and dash. We know people in restaurants, and Laura mentioned this, people in restaurants are under time pressure. They don't always have time to wash their hands, quote unquote, correctly or in a manner that is consistent with what's recommended in the US FDA Model Food Code, which is a 20-second wash with soap. So what we were interested in comparing was that ideal 20-second wash compared to a 5-second wash. We see evidence that people do this 5-second wash with no soap. I'm not going to ask you to raise your hands if you on the webinar have ever done this, but we know that people do this. And so the question is, what's the difference between washing your hands correctly and washing your hands incorrectly? So on the y-axis on this graph is frequency. This is the number of people in the study that got a certain log reduction effectiveness. So what you can see is for the 5-second wash with no soap, you get about a 1 log reduction. That's a 90% reduction in this bacteria that we placed on people's hands, non-pathogenic surrogate Enterobacter aerogenes. What you can see is that when you move from a 5-second wash with no soap to a 20-second wash with soap, you increase the efficacy of the hand wash. And again, you see a median response of about 2 or a 2.5 log reduction. A 2 log reduction is a 99% reduction. But you also see some people that are especially good hand washers, and there's one person over there at a 4 log reduction with soap and 20 seconds of hand washing. That person gets a 99.99% log reduction. But there's also a couple of people that even when they wash their hands with soap for 20 seconds, they are still not very effective in their hand washing. And so those 2 people only got about a half log reduction, or less than a 90% reduction. So what the key point that I'm trying to make from this one slide, and I see that I'm rapidly running out of time and I haven't even got past the first graph, is that there is a lot of difference between how people wash their hands and also looking at how they wash their hands. So even within the constraints of 20 seconds with soap, you can see that there's an incredible difference. The panel on the right looks at a 20-second hand wash without soap and with a paper towel or air drying your hands. And the punchline there is if you use a paper towel, it actually helps to physically remove bacteria from your hands. And so if you just let your hands dry in the air without using a paper towel, you don't get as effective a hand wash. Next slide, please. One of the topics I was asked to discuss is this idea of the Sani twice. Now, Sani, I mentioned before in my introductory remarks, Jim Mann works for Hand Washing for Life. It's his company. He has a registered trademark around the term Sani twice, and this is a 2-stage hand cleansing protocol performed using an ABHS, that's an alcohol-based hand sanitizer, when water is not available. So if you're interested in more details, I encourage you to take a look at that JFP article that's cited up there in the title of the slide. The bottom line is that under the conditions that were studied in this research, this Sani twice method is actually as effective as a non-antimicrobial or an antimicrobial hand wash. And so if you look at the panel on the right-hand side, that's the log reduction from baseline. And what you can see is whether you're using an antimicrobial hand wash, a non-antimicrobial hand wash, Sani twice with 62% ethanol, Sani twice with 70% ethanol, you get about the same effectiveness, and you get even better effectiveness if you use this 70% ethanol with this AF gel. So again, the tools and the techniques matter, but this shows that at least under some circumstances, you can get equivalent efficacy to a soap and water hand wash just using an alcohol-based hand sanitizer. Next slide, please. One of the other topics that I was asked to address was the FDA monograph on antibacterial soaps. And now to do this, I need to point out for you, we often, those of us in the food safety field, we talk about FDA like it's some monolithic agency. In fact, most of the time when we talk about FDA, we are talking about FDA CFSAN. CFSAN stands for the Center for Food Safety and Applied Nutrition. These are the people that basically are responsible for the safety of the food supply, as long as it's not meat and poultry. That would be USDA, FSIS. These are also the same people that publish the FDA Model Food Code, which they write in consultation with folks that attend the Conference for Food Protection. Now, when you move the discussion to antibacterial soaps, then you're really talking about a different part of FDA, and this is the FDA Center for Drug Evaluation and Research. And FDA CEDAR, as they're called, in December of 2015, they issued a proposed rule, which was open for public comment, which would require manufacturers of antibacterial hand soaps to demonstrate that their products are safe for long-term daily use and more effective than plain soap and water. And I've chosen to highlight those two particular terms because I'm really going to just talk about the second one, the effectiveness of these antibacterial products. There are some concerns, especially about compounds like triclosan, in that they may accumulate in the environment. I think that the concerns about the development of antibacterial resistance are probably not scientifically founded, but again, it's not my area of expertise. There does appear to be some science which indicates that these compounds may bioaccumulate in locations in the environment, and there may be some consequences there. But like I said, I'm going to focus on, are antibacterial soaps more effective? Next slide, please. And what you may have noticed from the previous slide on Sanitwise is that there didn't seem to be much difference. Well, this is based on some, this next slide is based on some data that, again, that we published based on a literature survey and meta-analysis. And what I want to share with you here, the punchline is that the difference between antibacterial soap and plain soap is small. It's about a half a log, depending upon how you measure it, but it is, in fact, statistically significant, and it is especially significant when you are measuring the effectiveness against transient organisms. And again, without turning this into a comprehensive lecture on hand washing, let me just point out that we tend to have two kinds of bacteria on our hands. The resident ones, the ones that are naturally there, that are part of having healthy skin, and the transient ones. Those are the ones that get on your hand from poop or from cross-contamination in the kitchen. And those transient organisms are much more effectively controlled by antibacterial soaps than the resident ones. So if you'll go on to the next slide, please. And again, if you're interested in more details, I certainly encourage you to take a look at that article. This is another paper where we also used a mathematical analysis to look at the effectiveness of antibacterial soap. And again, this is kind of a complicated figure, so I will walk you through it. What this is a computer simulation which assumes that we have a food worker, or we have a bunch of food workers, okay? And those food workers in our computer simulation, they start with 1 million Shigella bacteria on their hands. And then what they do is they proceed to handle a ready-to-eat food. In this case, this computer simulation assumes melon balls. And what we did in the computer simulation is we said, okay, you've got 1 million bacteria on your hands. Now you wash your hands, and you can wash your hands in one of 5 ways. You can use these 2 non-antibacterial hand washes, which are panels A and B on the figure, or you can wash your hand with an antibacterial product that contains triclosan, that contains chlorhexidine gluconate, or you can treat your hands, not wash your hands, but you can treat your hands with an ethyl alcohol-based hand sanitizer. And what the distributions represent is, if you were that worker and you had those 1 million bacteria on your hands and you did those hand washing treatments, and then you proceeded to handle melon balls, and then the simulated people in the computer ate those melon balls, if you were serving melon balls to 100 people, how many people would get sick? And so what you can see for panels A and B, which are the non-antibacterial products, you see about, on average, we did this computer simulation 10,000 times. And so what you see is, on average, about 50 people, about half the people that were eating those melon balls get sick. Sometimes the computer predicts more than 50 people, sometimes it predicts less, but on average it's about 50. What you can see for panels C, D, and E is that no matter which of the two antibacterial compounds you use, or whether you use ethyl alcohol-based hand sanitizer, the average number of people sick, or the median number of people sick, is significantly smaller. In some cases, you still may have 50 people sick, but it's much more likely to only be 10 or 15 people sick out of the 100 exposed. And those differences are statistically significant. And so this leads me to conclude that, based at least on our analysis, antibacterial soaps are, in fact, effective for their intended use. Next slide, please. I was asked to also talk about hand sanitizers. I've mentioned this already. I was asked specifically to discuss the differences between the CDC guidelines and what FDA says about that. There's a wonderful article published in Morbidity and Mortality Weekly Reports, one of my favorite journals to read. This was by Boyce and Pittett, published in 2002, entitled Guideline for Hand Hygiene in Healthcare Settings. And basically what these guidelines stated were that alcohol-based products, alcohol-based hand sanitizers, are in fact more effective than plain soap or antimicrobial soaps for healthcare workers. And just like food workers are under a certain amount of pressure to get stuff done, hospital workers or healthcare workers are under equivalent amount of pressure. And so one of the things that we've seen change in response to these CDC guidelines is we see much more alcohol-based hand sanitizer use in hospitals as an alternative to hand washing. Now, that's great for hospitals, but what about for food? Well, FDA, in the website that you see quoted there on the slide, FDA states as follows, that hand sanitizers may, in fact, not be effective against some pathogens that are transmitted in food service settings. The levels and types of soils found in food service and healthcare are, in fact, different. And FDA does make some valid points, but one of the things that I'm very pleased to see is that our research base in this area continues to expand, and I think, at least under some circumstances, hand sanitizers may, in fact, be an effective alternative for treating hands in food service applications. It's still not in compliance with the food code. Okay, you still can't do it and be in compliance, but in fact what the science says is that at least under some circumstances it works. Next slide, please. This is some of the work that we've done on hand sanitizers. And again, you can see the citation to the article there. Bottom line is that this is, again, using our Enterobacter aerogenes model system, applying 1 ml of alcohol-based sanitizer after the person has stacked and unstacked frozen hamburgers. And this was some work commissioned by a large food service company that wanted to find out if again, they know they have to, in the U.S., they have to comply with the food code, but what if they didn't? What if the workers didn't? What if instead of complying with the food code, they just use alcohol-based hand sanitizer? How effective would that be at controlling the risk? And so we inoculated the hamburgers with the organism. We had people handle the hamburgers, like to simulate stacking them on a grill, and then look at the effectiveness. And what you can see is that under those circumstances, with this particular organism suspended in pieces of partially unfrozen hamburger on people's hands, that in fact you see about a 2 or 3 log effectiveness. So that's a 99 or a 99.9% reduction in the concentration of bacteria in hands. Now, interesting, that data is interesting, but what's even more interesting to me is the text on the right side of the slide, which says that more than half the participants indicated that their hands felt dirtier than normal after handling frozen burgers. So in other words, they perceive their hands to have debris on them. And the investigators, the people doing the research in my lab, noted that half the people, at least more than half the people, had visible debris on their hands after handling the frozen burgers. And so what this begins to establish is that, in fact, antibacterial or alcohol-based hand sanitizers can be effective even in the presence of food debris, at least under some circumstances. And so, again, we're beginning to see the establishment of some science that's showing when these compounds can work. Next slide, please. What you can see on this next slide, this is some research that's not from my lab, but it is actually from some colleagues, published by some colleagues from Gojo and elsewhere. And you're going to hear from one of my other colleagues from Gojo in just a few minutes when I wrap up here. This is some work that they published in the journal Applied and Environmental Microbiology in 2008, looking at the effectiveness of viruses, looking at the effectiveness of hand sanitizers against viruses. And one of the claims that you'll hear from our colleagues at FDA is that, in fact, alcohol-based hand sanitizer is not terribly effective against some types of viruses, including norovirus. And so this is some research done with MS2, which is another virus that is used as a surrogate for norovirus. And what you can see is that, in fact, 78% ethanol is not very effective against MS2. That's the first bar in that bar graph. But if you modify that alcohol-based hand sanitizer to include citric acid or to include this this PQ37 compound, which is a polyquaternarium compound, that in fact you can boost effectiveness. You can go from a fraction of a log reduction to almost as much as a 1 log reduction. And when you combine those two, when you use citric acid in conjunction with this PQ37 compound, you can see that the log reduction effectiveness jumps way up to a 4 log reduction. That's a 99.99 log reduction. That is a very, very significant reduction. So what you can see is, and then in the Table 4, which is shown on the right-hand side of the slide, you can see that, in fact, if you look at the benchmark hand sanitizer versus this particular formulation that's been tweaked to include these additives, what you can see is that, in fact, you can make alcohol-based hand sanitizer that is more effective against some of these viruses. And so you can actually formulate alternatives to hand washing that are effective. Now, just briefly here in the time that I have remaining, I want to mention that even though folks from Gojo and from universities can go out and publish this kind of stuff, they can't actually make statements about that when they're marketing this product to their customers. And so they have to be very, very careful about what they say in the published literature versus what they tell their customers to do, because they can't, in fact, they have to follow some very, very restrictive regulations in terms of what they can tell people. Okay, finally, in the time that I have remaining, I want to talk about some work that I've done on bulk soap. This was some work that we presented at IAFP last year in a poster session. For those of you that don't know, bulk soap is basically soap that is used in some public restrooms that comes in open, refillable containers. And prior research has shown that these soap dispensers can become colonized with high levels of bacteria. So what we wanted to do in this research was to survey the microbiological quality of these samples in 3 different states in 4 different establishment types and look at a variety of factors that influence contamination. What we discovered was that about 12% of the samples we collected across all these states, across all these different locations, had high levels of bacteria, typically 10 to the 7th, okay? So that's 10 million bacteria per milliliter. The samples that had high total plate counts tended to also have high coliform counts, and what we discovered was that the solids content was correlated with high total plate counts. And so basically what this means is that people who have these open, not everybody, but many people that have these open refillable bulk soap containers, in an effort to save money, dilute their soap. And so they don't want to spend so much money on soap, so they take the soap, they dilute it out with water, and lo and behold, that leads to breakdown of the formulation of the soap, and it can lead to colonization and very high levels of bacteria, which is not good. This was especially common in grocery stores and fast food locations, less common in sit-down restaurants and convenience stores. Next slide, please. And I know that I'm slightly over time here, so I will wrap up quickly to give Dave plenty of time to talk. This is just some more data from that particular study, which shows that you can have high bacterial counts even in the presence of fairly high levels of these antimicrobial compounds. But in fact, most of the time, in most of these soaps that do have these high counts, you have in fact no antimicrobial compounds detected. And again, that work was presented at IAFP last summer, and we're working on a publication for that right now. Next slide, please. And so just to wrap things up, a couple of key take-home messages from me. Hand washing is not magic. It is risk reduction. It is not risk elimination. Remember, one of the very first slides that I showed you was that the food code compliant hand wash gives you a 99% reduction, but the 5-second splash and dash gives you a 90% reduction. So hand washing is good. It reduces risk, but it doesn't prevent risk, and that there is variability there. Just naturally from person to person, how we wash our hands makes a difference, and I don't think you're ever going to get rid of that variability. There's differences in people's skin types, etc. Antibacterial soaps that are being sold to the consumers may disappear. That's the FDA CEDAR proposal that I mentioned to you earlier in my remarks. The good news is, for those of us that work with food service and with other applications than with consumers, is that those are going to be treated separately, and so they may not disappear. But unfortunately, the rules that FDA CEDAR is going to place the industry under will make it not cost effective for those companies to make and market those products to consumers. Food service, the jury is still out on that. The data from our lab show that antibacterial soaps are more effective. There are other people who have conflicting results published out there, but in my opinion, they haven't done their studies right, or they haven't properly addressed the controls. But I believe antibacterial soaps do offer a benefit, and we've got a number of studies that show that. Hand sanitizer is great stuff. It can work in the presence of food debris, at least under certain circumstances, and so I would like to see some change in the FDA model food code. I'm not sure that's going to happen anytime soon. There are some very entrenched interests that are working against that, but I believe, based on the work that we published and that other people have published, is that you can get hand sanitizer that works in the presence of food debris and could be an alternative to hand washing. Hand sanitizers can be formulated to work better against viruses. Those virus effective formulations are more expensive, but they can indeed be formulated to work in that way. And then finally, as you're out there in the world washing your hands, be aware that if you are washing your hands with bulk soap, that bulk soap may in fact be contaminated with high levels of bacteria. And with that, again, I want to thank Shelley and Fight Back for inviting me to come and be a part of this webinar today. Thank you.
Thank you, Dr. Schaffner. This has been a great discussion, and now we have our stimulating question, poll question, for all of you. What do you think? Must proper hand hygiene always include washing with soap and water? This is, of course, something that many of you think about, and you probably get a lot of questions from people about this. So this is just your opinion and thoughts. Soap and water is critical. We promote soap and water and 20-second hand washing. All the steps that Laura outlined are the key messaging for the consumer. And this is just your thoughts on must proper hand hygiene always include washing with soap and water. So we'll leave this poll open for just about 15 seconds. We would love you all to vote. And we're going to try to keep on pace here. We do want to make sure we can get you guys back to your jobs. So we've got 62% voting. Please vote so we can see what people say about this interesting question. Must proper hand hygiene always include washing with soap and water? Okay. All right. So I'm going to close the poll here. We've got 70. Oh no more people are voting. So we're up to 76% of you voting. We can get to 80. I'd love that. All right. All right. Cast your vote so we get to 80%. We're at 79. Okay, we've got 80% people voting. So I want to share this with you. Very interesting. The majority of you say yes, there's no room for debate, that proper hand washing should always include washing with soap and water. That's what the majority of you think. And 33% of you say no. So thank you for that. All right. My screen's still showing, so I'm on track here. Okay. Dave Shoemaker with Gojo Industries. Dave, thanks for being with us. I'm just going to let you go right into your slides. I'm going to hand control over to you so you can present your slides.
All right, thank you, Shelley.
Thank you.
Thank you. There are a variety of test methods available to evaluate the antimicrobial performance of hand hygiene products. Performance evaluation is critical because product formulation can impact product efficacy. The methods that I'll discuss today are all ASTM methods. ASTM stands for the American Society for Testing and Materials, and according to ASTM, their methods are created to enhance the performance and help everyone have confidence in the things that they buy and use. Shelley, I'm trying to, there we go. Having a little trouble advancing the slides. Here we go. So the first method I'll discuss is ASTM E2783, assessment of the antimicrobial activity for water miscible compounds, or commonly referred to as time kill. This is an in vitro assay, meaning it's performed in a test tube. The way the method works is that the microorganism is added to the test product, either a soap or a sanitizer, for a short amount of time, usually between 15 and 60 seconds. Once the exposure time has elapsed, the test sample is then evaluated to determine the post-exposure population, or how many microorganisms remain. This method is very useful because it allows you to understand the rapid antimicrobial properties of a formulation. For example, can it kill bacteria such as E. coli or Salmonella in as little as 15 seconds? You are also able to test almost any bacteria, yeast, or mold using this method, so you can determine the formulation spectrum of activity, or what types of microorganisms is the formulation effective against. It does not necessarily, though, predict the antimicrobial performance of the products on hand. That is where in vivo methods are used. Can you go to the next slide, Shelley? Okay. The first in vivo method that I'll share is ASTM E1174, evaluation of the effectiveness of healthcare personnel hand wash formulations. In this method, hands of volunteers are contaminated with 4.5 milliliters of bacteria. The test product is then used, and after a 30-second wash and a 30-second rinse, the remaining bacteria are recovered. This cycle of adding bacteria and using the test product is repeated 9 more times so that the test product is used a total of 10 times. The reason for this is because in the healthcare industry, products are used repeatedly, so it is important to ensure that the products remain efficacious even after repeated use. So bacterial reduction is measured after wash 1 and wash 10, and in healthcare the guidance is that any hand hygiene product used must have a 2-log reduction after wash 1 and a 3-log reduction after wash 10. So product performance must improve after repeated use. This method is essentially the gold standard for measuring the reduction of transient microorganisms on the hands. That is ASTM E1174. And there's a lot of hand hygiene product performance data out there using this method for both hand wash and hand sanitizer products. But the method does have its limitations. For example, adding 4.5 milliliters of broth each time bacteria are added can saturate the hands and leave them wet. Wet hands can interfere with product performance of waterless hand hygiene products, And this method also does not take into consideration soil loads that you might expect to have in the food industry. So modified versions of this method have been created to take into account these variables. Next slide, please. ASTM E2755, determining the bacteria eliminating effectiveness of healthcare personal hand rub formulations, was created to address the need for a method for waterless hand hygiene products. The biggest difference between this method and the one previously described is the volume of bacteria added to the hands. In the last method, 4.5 milliliters of product of bacteria was added each time bacteria was added to the hands. In this method, only 200 microliters is added per application. So this smaller volume helps to avoid potential dilution of a waterless hand hygiene products. But there are limitations for this method as well. For example, there is the absence of any soil load. So an improved method should incorporate a soil load which is representative of the food industry. Next slide, please. And so ASTM E2946, determining the bacteria-reducing effectiveness of food handler hand wash formulations using hands of adults, is the most appropriate method for the food industry because it intentionally incorporates a soil load, either beef broth or ground beef contaminated with E. coli. Volunteers' hands are contaminated with the soil, and bacterial reduction is measured after a 30-second wash and a 30-second rinse. This method is specific for hand washes, but may be modified to test waterless hand hygiene products. This method could be improved if additional soil loads such as chicken, actual dirt, or organic plant material could be used to represent the needs of other industries such as farms, but it is the most appropriate method for food handlers. Next slide, please. As Don was saying, there are some nuances to claims that you can have on hand hygiene products. Examples of acceptable claims would be kills germs that can cause illness or reduces bacteria that can cause disease. Unacceptable claims include any claims against viruses or any claims against specific microorganisms such as E. coli, MRSA, or Salmonella, and any claim that claims persistent antimicrobial activity such as protects for 6 hours. And you may see products out there with these claims, but it is important to know that they are illegal under the US FDA OTC drug monograph. Next slide, please. I included this slide to demonstrate the variables which influence hand hygiene product efficacy. Many people assume that hand hygiene is simple, soap, water, 20 seconds, boom, done. But all these factors may have an influence on the efficacy of a hand hygiene event, and these can also influence how often you are willing to perform a hand hygiene event. So the product needs to be effective, but it also needs to be a product you are willing to use often. Next slide, please. So there was a fantastic article written a few years ago in Food Protection Trends titled Rethinking Hand Hygiene in the Retail and Food Service Industries, a recommended procedures based on the best science and practical under real-world conditions. In the author's opinions, there are improvement opportunities for hand hygiene in the retail and food service industries, specifically because low compliance rates observed in each industry suggest that current hand hygiene recommendations have not translated well into practice. To improve hand hygiene compliance in the food industry, the authors suggest prioritizing hand hygiene moments based on risk. We can determine critical control points by considering basic food microbiology principles along with observational studies of food handler behavior. We should engage in sites to understand motivations associated with lack of compliance. We could then use this to create a multimodal strategy to improve hand hygiene compliance. An example of a multimodal strategy is the World Health Organization's 5 moments for hand hygiene, which was created in healthcare to improve compliance rates. We need to study the risk-benefit of the use of alternative hand antiseptics, specifically when hands are not soiled or likely to be contaminated with viruses or spores, or after less risky practices such as eating or before gloving. We must improve our antiviral testing capabilities, specifically for norovirus, to rapidly validate product efficacy and facilitate approval for use in the food industry. And education, training material, policy, and practices should be revised to reflect changes in hand hygiene procedures based on sound science, risk, and practicality for food handlers.
Thank you so much, Dave. We have a great crowd on the webinar here, and I'm concerned because I want to make sure we are able to take some questions. So I'm going to skip the question for panelists and go right into our overview of resources. This will be very short. I want you to stay on with us. We're going to get to some questions. I'm going to quickly run through some of these great resources because I think it's very important for you all to know that there are tools out there, evidence-based materials that are free for your use. Thanks to all of our speakers, and we'll be back to them in a minute with your questions. So many of you have submitted questions. If you'd like to, please do so now. Hand hygiene resources for consumers. Many of these at fightback.org focus on kids. A lot of great things for teaching young people about hand hygiene, including a poster and a song. We developed a great set of materials called Crib Sheet, which is for caretakers to young children. So this goes for the daycare environment. So some really important information about hand hygiene there. And then just getting children to wash their hands. Of course, we need to get adults to wash their hands too. So check out fightback.org resources. The CDC has added some really great resources about hand hygiene, including the wash your hands, germs can live in 1 gram of poop, and a number of other very cool posters that appeal to different audiences. I very much encourage you to check out what the CDC has. They've got podcasts, they've got social media messaging, and videos, some really good and again free materials for you to use. Scrub Club is again for kids. It was developed by NSF International. There are various webisodes including The Good, the Bad, and the Ugly, different cartoon germs that are trying to get at you and make you sick. So scrubclub.org is a great resource, interactive material for young people. The CDC has also got a great page called Show Me the Science. It's the science behind hand washing information. I encourage you to check that out also and to reference the page and information directly from the page in your public presentations with consumers at health fairs, etc. Some terrific information. So we're going to go to questions now. Bear with me as I scroll down to find some of the questions, and I'm going to try to assign the question to a speaker. I have a question here, and I guess I'll ask Dawn to answer this. Dawn, are you able to? This question is, so the science shows either warm or cold water is effective for hand washing. Is that something, Dawn, you can comment on?
Yeah, in fact, that's absolutely true. The science, as I read it, shows that wash water temperature is not really a factor. Where water temperature does become important is in compliance. In other words, if the water is uncomfortably cold, people are not going to wash their hands as effectively. If the water is uncomfortably warm, people will not wash their hands effectively. And so the main point there is that the water temperature needs to be comfortable for someone to wash their hands. Unfortunately, the way the food code is currently written, there is no water temperature requirement in the portion of the code that tells people to wash their hands. There is a requirement in the plumbing section of the code, which I think still says that the hand wash sinks must be capable of dispensing water at 100 degrees Fahrenheit. So, but there is no scientific basis for that requirement.
Okay, thank you. Here's an interesting question, and this probably goes to retail food service, and Laura, I'm hoping you could take this question because it makes reference to the CDC. I am curious to know if the CDC has researched the use of nail brushes. In Minnesota, the Minnesota Department of Health requires their use, but I doubt they maybe are utilized routinely.
That's a good question. CDC hasn't done a whole lot of research on hand washing and nail brushes, so I guess I don't know for sure, but I guess the answer would be CDC has not done that, but and maybe Don can answer this, but I would guess that there are some research showing that nail brushes are more effective at getting germs out from under the fingernails than not using nail brushes.
Okay.
Yeah, that's exactly right, Laura. That if you have fecal matter or other things under your fingernails, probably the only way to really get it out is to use a nail brush. But then the question becomes, well, you know, what's the degree of compliance going to be with that? And so I guess what I'm in favor of, if you can't tell already, is giving people the tools they need to get their hands clean by whatever means. And certainly if you're in a situation where people are likely to have debris under their fingernails, you want to make a nail brush available to them. But there may be certain circumstances where you don't need to use a nail brush. And so again, you need the tools appropriate to the situation.
Okay, thank you, Don and Laura. There's, of course, a couple questions that are about the recent E. coli outbreak that's been in the news so much about Chipotle, and if it has been linked to inadequate hygiene practices. I don't know, Laura, if you're in a position to talk about that at all. Does anybody have a comment about that outbreak and any link to hand hygiene?
Yeah, go ahead, Don.
This is Don. I'll say a few words. So remember, Chipotle has had 6 outbreaks in 6 months. 3 of them were E. coli related, 2 were norovirus related, and 1 was salmonella related. The salmonella one was linked to tomatoes, and there's probably not a hygiene component there. We don't know what caused the 3 E. coli outbreaks. I suspect that they were probably, given the scope and the widespread nature, I would suspect that it's probably something to do with a contaminated ingredient. The 2 norovirus outbreaks are definitely related to personal hygiene. You had a sick worker who went to work anyway. And again, if you look at the way Chipotle does, at least traditionally had done a lot of their operations, they did a lot of preparation in the restaurant, you know, often by unskilled workers or by high school students. And so certainly in those circumstances, personal hygiene and compliance with, you know, food code recommendations are going to be very, very important. But I would say definitively, probably only 2 of the outbreaks could we really point to where personal hygiene or ill workers had a role, and those would be the 2 norovirus ones.
Yeah, this is Laura. I just wanted to add that Chipotle is actually on their website recently put up some information on the outbreaks and what they've done in response to those outbreaks. So if people are interested in Chipotle steps forward, it might be a good place to start. Hello?
Oh, I'm sorry. I was on mute. Hi, it's Shelley. For those of us who work with consumers, I think there's, of course, a real interest in soap and water. That is what we really advocate with the consumer. And there's an interesting question here from a woman named Betty. I'll just leave it up to all of you, and then we're going to probably just take one more question after this. Her question is, and I'm not sure who's the most appropriate person to answer it, but again, thinking about the soap and water method, why even if people wash their hands with soap for 20 seconds, it is still possible to not reduce 50% of the bacteria on hands? You know, Don, I think you were talking about just the variability. Can you say a little more about that as it relates to soap and water and the 20-second recommendation?
Sure, absolutely. So soap and water, the data that I showed that 20 seconds with soap and water gives you, on average, about a 99% reduction, which is pretty good, unless, of course, you have 1 million bacteria on your hands. And 1 million bacteria multiplied by 1% is still a whole lot of bacteria, and certainly enough to give you a relatively high chance of getting sick if those bacteria are foodborne pathogens. So think of hand washing with soap and water as giving you a 99% reduction if you do it correctly. But there's going to be variability from person to person. Some people, and you'll notice this if you just take a look in any public restroom, and if you watch people wash their hands, there are some people that really do a good job. I think friction is probably one factor that we haven't really studied very well. Friction, wetting your hands, the technique that you have. How do you just wash the palms of your hands and your fingertips? Do you do a good job of washing the backs of your hands? Obviously the palms and the fingertips probably are more likely to contact food, so you probably should try to do a better job there. But it is complicated. And again, one of the take-home messages that I will, from my talk, which I will reemphasize, is remember that think of hand washing as a risk reduction activity, not as a risk elimination activity. Just like wearing your seatbelt will help you if you're in a car accident, it's not going to keep you completely safe. There still are risks, and hand washing is just one tool that we have to try to mitigate those risks.
I think that's extremely important, and for all of us to keep in mind as we talk about reducing risk of foodborne illness, and all the messaging. Here's an interesting, and I'll make this the final question, and then I want to do a couple closing things, including preview for you some of our upcoming events. This might be something Dave could answer about. Someone asked, Dawn is asking, do hand sanitizers not strip our hands of natural oils that we need to protect us? Do hand sanitizers not kill the good and bad bacteria and set us up for superbugs? I don't know if that's probably a hard question to answer quickly, but Dave,
sure. I think I can take it in pieces. So the idea that a hand sanitizer might strip your hands of oil, that's not the case, because there's no removal during the hand sanitizing process compared to soap and water when you're lifting and removing oil and germs off your hand down the drain. As far as the resident versus transient microorganisms or good versus bad bugs, the thought there is that the hand sanitizer really is most effective against the germs on the top of your skin, and not so much the germs in the deeper layers of your skin where the resident bacteria are thought to reside. But we are paying attention to that topic and staying on top of the latest research and science, and to understand efficacy of hand hygiene products and cosmetic and personal care products on the microbiome. Okay. And as far as super bugs go, the way that alcohol works, it's effective because it's not specific in its killing ability. The way you get antibiotic resistance is that you have a specific microorganism system that you're interfering, or you're interrupting a very specific process in a germ. The way alcohol works is that it disrupts the entire cell membrane and really totally annihilates the microorganisms. So there's no chance for resistance, and the fact that alcohol evaporates and leaves the skin and does not reside on the skin, or does not remain in small quantities, again, is another reason why it does not promote antibiotic resistance.
Okay, thank you, Dave. We have so many questions. There's a lot of questions about people who are concerned about schools and the fact that young people don't get time to wash their hands. A lot of thoughtful questions. So what I'd like to do is go through some of these, and we'll probably do a follow-up e-card or email or something in which we address some of these questions. It's just been a really good discussion. I want to thank all of you for attending. We had an amazing attendance. So we will do some follow-up on this. You should also note that this webinar will be posted to YouTube. We will also be posting information at fightback.org. That's the main website of the Nonprofit Partnership for Food Safety Education. If you're not familiar with the partnership, our work is to develop and promote effective education programs to reduce foodborne illness risk for consumers. And much of what we do is serve the educators who are working with consumers to make sure you all feel informed and feel prepared and have great material to use with consumers. Some of our upcoming events for backfighters include a knowledge exchange, which is a conference call format, in March on what we're calling All Things Egg. These are short calls intended to just give you a great overview on a topic and allow you to ask some questions. And then a webinar in June that's going to look at nutrition education and the integration of food safety messaging with nutrition education. We will join you to our e-list. I want you to know that our weekly emails almost always include a specific download you can use, research you can use, and or notifying you about events like this that are being sponsored by the partnership. We thank our leading sponsoring partners for the support. We are a not-for-profit. Our work, again, is really to develop and promote effective education programs for the consumer. I think we all got some terrific information today from Laura, Don, Dave. Thank you all for being with us, and continue to look for more information from the Partnership for Food Safety Education and the Backfighters Network at YouTube and Team Food Safety on LinkedIn. Thanks so much for being with us. Bye-bye.